Okay, index views in the Enterprise Edition of SQL Server is a fantastic technology and something that every reporting person should be aware of and should try to utilize whenever possible. It makes your queries instantly hundreds of times faster if utilized right. Sometimes in the past you might have done some of these kind of things by creating additional aggregate tables. Okay, so for example, let's say you have a reporting system that reports on sales, and you go from date to where you click on and you show all the dates and all the sales amounts. Then you might click on that row for a certain date and it will drill down into the store and break that out by store, all the sales for store amounts. Then you break that out and it might break that out by product, each of the stores and what they sold of that product, right? Okay, but let's say you're going against an extremely large table. In the past, what people would do to make this fast, you'd have to, in order to get this out of a very large table, you'd have to do a group by. You'd have to group by date on the first screen, and then on the first drill down, then the next drill down, you'd have to group by date and store, and then the next drill down, you'd have to group by date, store, and product. Okay, and against a very, very large table, even with indexes created that to help it, this can be quite a drag on the system and on your report. So it might take 20 seconds or even a minute or even longer between each click, and that's not the kind of reporting these days that most users expect. Now, I'm not even talking about cubes. I'm just talking about regular relational data warehousing. Okay, so what I want to show you today is a fact sales table that has about 500 million rows, which isn't unbelievable for a lot of companies. This is not unusual. So, but it is painful if you don't have indexing already created on it. And even with indexing, the group bys can be quite slow. And going back to our example, what some people did as they go through that report where they drill down, they might actually behind the scenes go to different tables that they had aggregated in the past and do selects against those in order to improve the speed of the queries. Unfortunately, with these separate aggregate tables, it was difficult. You'd have to code around, do a lot more coding, because on every click you wouldn't use the same table. It would go to a different table, and you have to be very aware of where that was. And it became a lot more coding maintenance to be able to do that, and you had a lot more tables in your database, so it complicated a lot of areas of the system. Okay, so anyways, just to demonstrate, first of all, a very simple report. We're just returning back date key, account, and a sum of sales amount by date key. Okay, so very, very simple as our example goes. And I'm just going to create a non-clustered index on the date key and include the sales amount. And this is basically is a covering index. So when it runs this query up here behind the scenes in the report, it won't have to go out to the entire table. It'll be able to go to the index and get the data from the index. Okay, it looks like the index completed. And what I'm going to do is turn on the actual execution plan. And to run this without an index that it's going to use on 5 million rows, we could wait all day. So I made sure I got an index that we're going to be able to use. And what we're going to do here is turn on the execution plan so we can take a look at that afterwards. I also want to set statistics IO on so we can look at how many page reads, because that's not a perfect indicator, but quite a pretty good indicator of how resource intensive it is, or at least at the minimum how resource intensive it is. You can't tell what it's doing in TempDB because sometimes work tables are created there, so you can't see how much pounding that takes. But you can see in general how many how many pages come back to some minimum amount. Okay, so what I'm going to do here is I'm just going to set statistics IO on. Okay, and we're going to also go up to query, and I'm going to display include actual execution plan. So when it finishes, it's going to tell me whether it used this index or not. That's really this index or not, which I'm assuming it will because it covers everything in this query. Okay, so remember, this is the query one of the queries we're going to use in the report, and we're going to see how this works. So I'm going to set statistics IO on, click there, and then I'm going to go ahead and run this guy, and we're going to see how long it takes or how much IO it consumes to get to finish this report. Okay, so execute. So as you see, it's executing. I'm going to pause for a moment and come back when it's done. Okay, as we look at the execution plan, we can see that the data here, and if you looked under object, that's what's object is looking at. It does an index scan, so it's scanning the index. Now it's not the clustered index scan. If it's scanning the clustered index scan, then it's scanning the entire table. Okay, here it's doing the non-clustered index, just an index scan on this object called object, under the object field here, which is, you see, that's the non-clustered index we created. Now remember, that non-clustered index, all it has in it is the date key and the primary key, which is, it isn't part of the definition, but under the covers it has the primary key also. But anyways, it's very skinny. It's the date key is an integer, and the primary key is, I believe, an integer or a big int. So we're looking about 16 bytes. So it's not like the entire table, which might be, I'm not sure, but maybe 150 bytes or so. Okay, so it reduces the number of pages it has to return because it's covering. I'm sorry. It also will include the sales amount field, which is another several bytes. So basically, all in all, it's still returning only a very small subset, as opposed to returning the entire table, the entire row of each one. It's just looking at the index, okay, which reduces the number of pages that it's returning. So it is fairly efficient, right? But as we're moving towards our real goal of this lesson, is what is the effect when we go to these things called index views. So I have 3 index views I'm going to create. I'm going to create the first one real fast, and we're going to compare it. And this is the index view. So I'm creating it. You have to use, there's certain syntax, you can look this up. You have to use schema binding. There's some restrictions to the index view. So you can go and look all that kind of stuff up, but to give you how it works in general, we're going to create the view, and it's basically a view exactly on the query we just ran, right? But it's not going to store. It's only going to store the result set in this index view. So the index view, right? There's nothing stored in the index view. So when I execute this, it's going to be immediate to create the view. That's just the metadata. The real punch that happens is when to persist the data that's the result of that view, and what makes it all so fast is when you create this unique clustered index, okay, on the view. So here's it says create unique clustered index IDX date on the view. That's the view name I just created. Actually, it's by date, right? That's it. That's the view I just created up here, and then it gives it the key I'm going to create it on. Okay, I'm going to go ahead and run this clustered index create this clustered index, and that's going to take a while to run. Okay, so I'll be back after that finishes. So then I create the index view, which is only on the date in this case, and we'll see how this performs compared to the one that uses the earlier index. Okay, my index view is finished. So what will it do when I run the query? Will it use my index view, or will it use the index I created up here, the non-clustered index? Now remember, the index view is a view that's totally somewhat removed from the actual table. So here it is, the view is here, and ironically, oh, there we go. The index shows up here, which is nice, but it's not part of the table. It's actually, which we're pointing at, which is over here, fact online sales. You won't see the index view here or that index that we just created. Okay, so you don't see either here. So do you think it's going to use, when we run this query against the base table, do you think it's going to use the built earlier, which took about 3 minutes to get a result set back, which is, where is that guy? Sales queue. I think we have to refresh it. Okay, open. Here it is. That's the one we created earlier. It took about after we created it, took about 3 minutes to retrieve the data. And really it's based off of the same thing that our view is based, our index view down here is based off of. So which one is it going to use? Is it going to use the index view in the execution plan, or is it going to use the regular non-cluster index that it used initially? Well, let's run it and relieve the suspense. I'm going to set the statistics on. We have our execution plan on, and here we go. Let's execute it. Remember, last time it took about 3 minutes to return the data. So let's see how long it takes now. Did you see that? Was that instantaneous? Was that at least 100 times faster? It was. And that is the power of the indexed view. I could stop the video right now with that statement right there. Okay, and we can prove that if I go to the execution plan and I look to see what it did. It did a clustered index scan, but what did it do with it over? That object is the indexed view. So it can go out immediately and get that data from the index view. It knows that the index view is associated with it. Of course, maybe the schema binding tells it that, because you can't change anything in that base table unless you remove the index view first. Okay, but that's part of the deal. All right, so that's why we got instantaneous. Now let's look at the number of IOs as far as how much it had to go out and read. What is this? 8. It's ridiculously, unbelievably small. That's why it's instantaneous. It's done all that pre-aggregation inside the index itself. When we ran it earlier and without the indexed view, and it used the non-clustered date include sales amount index, it came back with, and I wrote it down here, 3,732,877 pages of I/O to get the result. And that's why it took 3 minutes plus to get a result set. Okay, 8 pages versus 3,732,000, and that's 3,732,000 if you use an index. If you didn't have an index, that could have been 20 million. Who knows how many million that would have been. Astronomical. Okay, so using an index is good, but it's nowhere near what you can get when you use an index view. Okay, let's pause and take a breath. I know that was pretty exciting, and we'll continue now, okay, to a new part of this lesson, but I just want to slow down and change gears a little bit here. Remember I talked about how before you had to create these aggregate tables and then do coding in between all over the place to, for this scenario you use that aggregate table, for that scenario you use this aggregate table, etc. Now it's all baked in to the and synchronized with the base table itself. It goes out and finds that index view, which acts as like an aggregate table, but it automatically does it under the covers if you have Enterprise Edition. If you do not have Enterprise Edition, it will not do this. Of course, you spend tons of money for Enterprise Edition. If you got it and you're not using this, it's such a beautiful thing here. When you have Enterprise Edition, you do this. Now, I have another video that talks about Standard Edition, and you can do a lot of this in Standard Edition, but you can't do this part where you can call it from one place. So what does this mean? This means if you have a relational data warehouse that lends itself to this technique that you're not using, you could inevitably create these index views without ever touching any of the reporting system or any of the code or any of the stored procedures you're running against, and it would automatically grab the index views and use this index view behind the scenes. So you wouldn't have to touch the reporting system or anything, just go to and create these index views. That's if your code, your aggregates lend itself to this technology. It lends itself in the way and what it's trying to return. I mean, if it's trying to return extra rows that aren't in the index view, it's not going to work. So, but in some cases, you'll be able to increase your response time for your report users many fold just by using index views. So you need to maybe do some inventory of your code and of your tables and of your queries and your reports to see whether this could be utilized. And if it can, you're going to get an incredibly big bang for your buck. Okay, I'm going to continue this now. I just want to emphasize that this is what we're seeing. This is where the bang is, right here. But I'm going to now the rest of the video. I'm going to go ahead and create 3 other index views on the same table. The next one's going to be where it's going to be date store, so it's a little more granular on the group by. And then the one after that's going to be date, store, and product. Remember the scenario I said where you drill down from date to store to product, okay, in some report you have, okay, or interface for your user. I'm also going to create a report that does that. Okay, so we can actually use this behind the scenes, and we're going to see how fast you can traverse aggregates on a 500 million row table, and that's going to be pretty cool. Okay, so right now I'm going to go ahead and create these other 2 views. Okay, we already created the date one. Now the next one I'm going to create date store, which you see here. I'm bringing in date in the store. I'm doing the same thing with the sum of the sales amount. You can have all these aggregates spread all the way out, okay? So don't think you only have to have one. Count big you have to have. That's a requirement of any index view. And here, this one again, you have I have the index, and I'm creating it by date, key, and store. Okay, and then here's my date, store, product view, which is even more granular. I group it by the product. There we go. Everything looks cool. Oh, wait a second. Where's my clustered index? I got to create a clustered index there. So let me just copy that, and we're just going to call that store product. And I add product down here, comma, product key. Okay, and that looks good. Okay, so I'm going to go ahead and run this, and when it finishes, I'm going to come back. Now, when it first creates one of these index views, creating the view itself is easy. Creating the clustered index that persists that data, that's going to take a while. So if you got a huge table, prepare to wait a while. I mean, some of these took about 25 minutes, 30 minutes. They could take hours. The more complicated the group by is. Okay, the more aggregates you have in there, it might take longer. So prepare yourself. You could, if you want to kind of figure out how much time it's going to take. You could put a where clause in here and just say, give me a top 20 million, and or top 10 million, and let's see how long that takes to create it, just to get yourself a baseline. So how for you can plan your evening or how long your job's going to take. So you don't run into other processes and you find the right window of time to do this. Okay, so here we go. We have the create view. We have the create clustered index there. I'm going to highlight those. Oops, boy, this thing has a speeding ticket on this thing. Let me use my keyboard. Like a roller coaster or roller skates. Okay, so I'm going to run these two and then we're going to come back. Okay, to conclude this video, I created a report that does that drill down that I talked about, from the date to the date store to the date store product for anywhere in the Fact Online Sales. Now, let's remember, the Fact Online Sales has 517 million rows. Okay, and this report I generated is able to perform at incredible speed because of the index views I have on it and the way they work under the covers when you run certain queries. Okay, so I'm going to go ahead and show you these reports and the astonishing performance you get from them. So remember this number. The number of rows is 517,731,928. Okay, I'm going to run the report now. Preview. And notice at the top, there's our count of 517,731,928. Then here is my first level. This is where it's hitting the date index view. Okay, and as you saw, it comes back extremely quick. This it's not necessarily cached, but I'm just going to go through all these pages, right? And I'm just going to, okay, it goes up to 2009. Okay, and all these numbers. So let's just pick one. Okay, just I'm going to pick the top one up here. 2009-02-22. Okay, remember these numbers, 480, 87, 724. Okay, I click there. 2002-22, 480, 87. Okay, I'm going to click down on one of these stores, 307. I'm going to click on, and that is 148 and 27 sales amount. Okay, let's remember those numbers. 148, 27 sales amount. Okay, with the index views, it's immediate. I'm hitting a table of 517 million rows. Okay, because the index views are pre-aggregated, everything is at my fingertips. I can drill down from anywhere and get this kind of speed. Okay, so that's 2000. Let's just go back a couple. Let's go back and do 306, which is 172.30 for this date, and it's immediate. Okay, this is when you design and architect it and model it correctly and use the index views, you can do extremely fantastic things when it comes to performance. Okay, so now I'm going to go back. I'm going to take another one at random. Let's take this one at the bottom here. 2000. Okay, 0325. 407 is the count. 80 million is the amount of money. Okay, 0325. 407 is the count. 80 million is the sales amount. Okay, 0325. Drill down on 306. Let's drill down on 199. We should see 104 and 31 broken out by product. There's our total, 104 and 31, broken out by product, pages of product. Okay, just to show you the code I have behind this, and you can pause the video and look at it more, more carefully. But if I go to my main report, there's really three reports. It goes from date, which is a hyperlink, and that goes to date store report. And date store has a hyperlink, and that goes to date store product. Now, you got to know some reporting services to do this, but basically there's three reports here. Okay, one calls the other. Okay, they all kind of look the same, so it can appear to be one report. Okay, so on my main report, I have a data set. Okay, so if I look at that data set, again, this is really simple. This is really basic queries. So here's the select command, select date, just like I showed you in the earlier part of the video. Okay, so that does basically does that, group by that, and that's how it's using. As long as you write this query right, it's going to use the index view under the covers. Okay, okay, but I'm still calling the base table, right? I'm not calling the index view directly. You could, but I'm not. I'm calling the base table. So that's the main page. When I do the date, when I go into the date store, it will look similar. But I add the store key. So you see the store key is in there. And the store key is in the order by and then the group by. But this again is using the index view, but the index view that's set up for date store key. Okay, not the one that the date key used on the first report that I just showed you. So they all will use, but again, as you look at it, it's calling against the base table. The query optimizer will figure out what index view to use. So when you have a base table, you can have 40 index views against the base table if you want. Okay, and maybe that's not unheard of. I'm not sure, but I know it works, and it works very well in many cases. Okay, and the last one was a state store product, right? And you look at that. No magic, no secrets here. Again, it goes against that same base table that the index view is stationed against. And you know it has to be using the index view because of the speed. You can't get that kind of speed without the index view. You'd take 3 minutes between one disk if you just had a regular index on it. That is using it. Your covering index, in fact, still take 3 minutes because of the size of the table. But the index views are instantaneous practically. Okay. Okay, and that's going to conclude my demo on index views in Enterprise Edition. This concludes this video. Please come and see more of my videos at www.sqlcoop.com. Thank you.